Everybody, so let us try to solve a trie-based problem. It's a very famous problem called maximum XOR. It's a LeetCode 421 question. I would highly suggest for anyone who is just learning about tries to view the introduction to trie video, which is a part of the current playlist only. I will keep it in the description as well. So first, let us understand what is even XOR. So uh, in your digital circuit courses, if you remember, if there are two bits A, B, 0, 0, 1, 1, 0, 1, 0, 1, and A XOR B, the value is 0, 1, 1, 0. How I remember this particular XOR function is whenever the two bits are different, that is, in these two cases, a and b are diff not equal. It is 0, 1, 1, 0. The output is 1. Whenever it is same, it is 0. So this is the definition of XOR. And what do I mean when I say XOR of, let us take randomly three numbers, 3 and 10. So 3 can be written as 0, 0, 1, 1. That is, this is 2 power 0, this is 2 power 1, 2 square, 2 cube. And 10 can be written as 2, 8 plus 2. So 1, 0. When I say XOR of 3 and 10, we get whenever it is different, we are setting the bit as 1. Whenever it is same, we set it as 0. 0, 1. So this is nothing but 2 cube plus 2 power 0, which is 8 plus 1. So XOR of 3 and 10, 3 XOR 10 is 9. The question is that we are given a vector of numbers. Let us say we have a vector of 3, 10, 5, 25, and so on. We have to return from which two numbers if we XOR, for example, 3 XOR 10, 3 XOR 5, 3 XOR 25, whatever it may be, we have to return the maximum XOR which we get. So this is the understanding of the question. We'll see how to solve this. Let us work with the following vector 3, 10, 5, 25 to 8. I've also written the bit representations of each number and above are the values at each bit. So one straightforward solution is that for every two numbers, we can find the XOR and return the maximum solution. So that solution would be taking O of n squared time, where n is the number of elements in the vector. So this solution would give us a TLE as our constraint for n is 2 into 10 power 5 elements. That means we need to optimize the solution in one way or the other. So let us see how we can even approach the optimization now. Try to understand when does the XOR becomes maximum. For that, let us take this case of 3 and 10, XOR between 3 and 10, and XOR between 3 and 5. Okay, I'll write the bit numbers as well, just the last four, and 1, 0, 1, 0. The XOR is 1, 0, 0, 1, which was 9. And here it is 0, 0, 1, 1. And for 5 it is 0, 1, 0, 1. And we get 0, 1, 1, 0. This corresponds to number 6. The XOR between 3 and 10 is greater than XOR between 3 and 5. This is because if you look at the set bit, the leftmost set bit is actually set. For example, uh, in our case, this is 2 cube. 2 cube would always be greater than sum of all the numbers. For example, 2 square plus 2 power 1 plus 2 power 0. For example, if it had been 0, 1, 1, 1, this is still, this 1, 0, 0, 0 bit is still greater than this particular case, is what I am trying to show here. That's why the criteria becomes if at all we are able to set the leftmost bit, that would give us the maximum XOR. So let us see how a trie would help us in solving this problem. So first I'll insert all these elements into the trie in bitwise fashion. Because all of these elements are anyway 0, I will just insert the final 4 for now, for this particular example, for our understanding. Okay. Only inserting these values. So we have a root, node, and now we'll be having only two children, one for 0 and one for 1. So the left one I will consider as the 0th bit. When I insert 3, it is 0, 0, 0, 1, 1. So I would go about 0, 0, 0, 1, 1. Okay, 3 has been inserted. Now let us insert 10, which is 0, 1, 0, 1, 0. So 0 is already there. We get a 1, 0, 1, 0. Similarly, after adding all the numbers, I will also mark the end of each node with the green colored title. This one, this one. Similarly, we get the following tree after adding all of them. We have inserted all the numbers into the trie and we have this current trie. Okay, now we want to find with number 3, what is the maximum XOR I can get? Okay, we remember that we want the different bit at every step. So for 0, 0, 0, 1, 1, first is a 0. I'll be standing at the root checking, okay, my current value is 0. Is there a 1 present? Yes, 1 is present. That means at this bit, I can set a 1. I will move here. Okay, the next current 3 is 0 again. Is there a 1 present? Yes, 1 is present. So I can move here and I can put a 1 here. Now the next is 0. Now, is there a 1 present here? No, it is not there. So we will be moving to no other option, but we have to move here itself. And there is no increment in XOR value. Okay. Now there is a 1 present. The next bit is 1. And that's nice that we have a 0 here, like opposite of 1, 0. And we'll move here and it will increment the XOR value. And finally, there is a 1 here and there is no 0 present to this child. That number doesn't exist. So we'll have to move here and put a 0 here. So this is the XOR we get with maximum XOR, including 3. Now let us see what would be the maximum XOR with 10. I'll change the pen color for this. Okay. Now 10 bits are, first bit is 0. So from we'll be standing at the root and say, okay, my bit is 0. Is that the opposite exist? Yes, it exists. So I'll come here and it will also set 1 here. Now the next bit is 1. Now does the opposite exist? That means a 0. This does not exist. So there is no other option, but I have to go to this child and it will put a 0 here. Okay, now it's a 0. Does the opposite exist? 1 exist? No, this does not exist. So no other option. I have to go here. We'll put a 0 here as well. Now it's a 1. The opposite exists. That is 0th child exists. That's why it becomes a 1. And it's a 0 here. 0, the opposite child exists. That is 1. So I'll move here and the answer would be this one. So similarly, if we fill these values for the other values as well, the final answer would be maximum of all of these values. In this case, this is this one, which is nothing but 2 power 4 plus 2 cube plus 2 square, 16 plus 8 plus 4. So the answer is 28 for this particular vector. We will see how to code this one, but the main logic is we first have to build the trie and we are traversing the trie such that for every index we are looking if the opposite children exist or not. And if it exists, we increase the XOR. If it doesn't exist, the XOR value does not increase. So what is the time complexity in our case? For creating the array, it is order of length of each number. That is, for an int, it will be 32 bits. So 32 into n is for creating. And for searching, again, it would be the length of searching the maximums, or it is again the length of each each integer, that is 32. And that we are also doing for n times. For the total complexity would be 32 into n plus 32 into n. So more or less it is 64n, which is less than O of n square. So this would pass all the test cases. We will see how to implement this in the C++. Okay, so now let us see how to code the solution which we just discussed. First, we will define the node class. Okay, node class, and the public properties are one is a node star. I'll call it left and right instead of creating two node children because we know we are having only two children. And in the constructor, I will initialize the left and right to null pointer. Okay, now we have defined the class, and the first step we need to do is we have to create the trie. That means we have to insert each and every number from nums into the trie. Okay, so first I will initialize the trie, that is my current root is equal to new node. Okay, the root has been set up, and for each number int n in nums, I'll define an insert function which will insert in the current number in the root. Okay, so let us define insert. Insert, it is taking two parameters. First is a node star root and integer n. Okay, now I will define the current node as root. We'll start from here. Now for each integer n, we know there are 32 bits. 32 bits in n. For I'll start from the leftmost bit. So int I is equal to 31, as 0 to 31. I is greater than or equal to 0, I minus minus. We should find out what is the current value of the bit. Is it 1 or 0 at 31st position, at ith position? So for that, int b is nothing but the current number n. I will AND with what value? With 1 when I am left shifting it I number of times. That means, for example, if I is equal to 31, that means at 31st position there will be 1 and all zeros. Okay, this when I do an AND with n, if and only if there is a 1 present at 31st position, we'll get a value, otherwise everything would be 0. Okay, like that we'll find the bit b. If b is equal to 0, that means the b the at 30 at ith position the value is 0. If b is equal to 0, I would want to insert at the left one. So if my current node's left is also null pointer, that means it has not been initialized yet, then I will initialize current left as a new node. Okay, as a new node, and my current will also move that. Okay, current is equal to current left. Else, that means the bit is 1. That means I would have to initialize the right one. If current right is equal to null pointer. If it is equal to null pointer, we have to initialize the current right is equal to a new node and move the current to current right. Current is equal to current right. Great. You might have wondered, like in this case, I'm not using is and boolean as we have used previously. This is because we know each number, each integer will have exactly 32 bits. So we don't really need to specifically mark a node as an end or not. For each case, we will definitely travel 32 number of times. Okay, so now our trie is created. Trie is created. Now we have to find, uh, for each number, we will find what is the maximum XOR we can get. So for, let us say, int n again, in nums, I will say my current answer. Okay, my current answer is equal to get max XOR. We'll write this function. It will take the current number and also the root of the triad. Okay, my final answer, I'll initialize it as int answer as 0, as XOR of any number with itself would always be 0. So that's the minimum we could get. And my final answer would be maximum of answer and current answer. And we will return the answer. Okay. Now we have to implement get max XOR function. It is returning an integer. Okay, int get max XOR, taking an integer n and the pointer of the root. Okay, answer fine. Now we will define the current node where I'm standing at as the root. Okay, and right now the answer I'll initialize to 0, and wherever I'm able to find the opposite child, we'll keep on incrementing the answer. So for int, similar to the insertion logic, we'll go bit by bit. For int I is equal to 31, I is always greater than or equal to 0, and we'll reduce I. Now my current bit is equal to same as the logic before. My current number n, I'm ANDing with 1 which has been left shifted, I number of times. Okay, so if current bit is 0, that means we want to see if right child, that is the child corresponding to 1 exists or not. If my current node has a right children, that is it is not equal to null pointer. If it is exists, that means I can increment the answer. The current XOR is incremented by how much? That is 2 power I. Okay, so answer is equal to answer plus 2 power I, and I will move the current pointer to current of right. If it does not exist, that means right child doesn't exist, then I'll not increase the answer, but I will just simply move the current pointer to current of left. We don't have any other option. Okay, similarly, if this else condition, then my current bit is not 0, current bit is 1. So in this case, I will check if current left pointer is not equal to null pointer, It is not equal to null pointer, that means I can increment the answer, increment by power of 2 comma I, and current is equal to current left. Okay, as my current bit is 1 here, current bit is 1, I'll move in the opposite direction if it doesn't exist. If it exists, if it doesn't exist, I am not increasing the answer. We will just simply move in this available direction, current right. Okay, so in this for loop, we increment the answer and finally return answer. Okay, let us run and see if we made any mistakes. 927. Okay, current is equal to current right. There is no. Okay. Okay, let us submit and see. Okay, this is accepted. So this is one of a very important question. I hope you practiced many times before appearing for any interviews. Okay, thank you so much. Please subscribe